number 5 was one of the most highly missed questions on this test. And here's what's happening, right? You guys are really great at finding the values, have a product equal to AC and a sum of B, right? That was great. The problem is that if A isn't 1, you're not finished. And really, I encourage you, once you write down something that you think is the factored form of a polynomial, please just take a moment and multiply it out mentally. If I can go back to question 4 that we just did, when I claim that this is equivalent to this is the factored form of the polynomial quadratic above it, it just takes me a moment, and multiplying x times x, I get x squared, and then I've got 7x, x times 7 is 7x, and then I've got negative 5x. When I combine 7x and 5x, that is clearly 2x, and then finally, when I multiply negative 5 times 7, I get the negative 35, right? So it doesn't take me long to see that this thing that I've written down here is exactly equal to the thing above it. That's so important. And several of you, I don't know, a lot of you, that's probably exaggeration, but many of you, I felt, were just simply finding these numbers, writing it down, and then not even considering, hey, this isn't even equivalent to what the polynomial, the quadratic that I started with. So let's look at the AC method, right, that we discuss all the time. Here I've got 5 times 13. Well, that's a problem, right? One of the first problems is this is not even written in standard form, and if I'm going to solve it by factoring, I need to have it equal to 0. So I need to rewrite this thing. First of all, I'm going to rewrite it as 5x squared, and then I'm going to have a minus 13x, and then finally negative 6, and that will equal 0. So I took the original equation I was given, and I subtracted 13x from both sides. Totally legit because of the subtraction property of equality. And I have this new form that's exactly matches the form of the equation I had above it. Now I'm looking at AC. A is 5 and C is negative 6. I'm going to write this down here. A is equal to 5, C equals negative 6, and B is equal to negative 13. Negative 13. So I'll go ahead and write B down here. B is negative 13. And A times C is going to be negative 30. So if I think about the factored form of negative 30, that's 6 times 5, which is a 2 and a 3. That's my 6 times a 5. And I could be using a factor of 1. And I'm going to need, some negatives here. In fact, one of these two numbers, I don't think I have to play with both of them. No, they both can't be negative. For sure, one of them has to be negative. So what I'm doing here mentally is I'm looking at the factored form of negative 30, and I'm trying to see how I can form the number negative 13 out of it, and still have a product of negative 30. It doesn't take me long, right? I'm clearly that this 2 and this 5 have caught my eye. That's a 10, and what I'm left with there is a 3, and I'm like, wait a minute, that's not going to work because 10 plus 3 is 13, and I need a negative 13. I can't, both of these can't be positive, so that's not going anywhere. I'm so disappointed in myself. I see it. I see. If I break them up like this, right, one of my factor is going to be 15, and that 15 can be negative, and what I'm left with is a positive 2. So I'm looking at negative 15 and positive 2. Now, it's a mystery what's going on here, but I think, if you camp out and look at these factors for a while, our goal is always to get two numbers that have a product equal to AC, and you can see these two numbers, when I multiply them, they will equal negative 30, and they have to have a sum that's equal to B. When I add those two numbers, negative 15 and 2, I do get negative 13. Now, that's great. Here's what I saw many of you do. You found these numbers and you wrote this down. You wrote down x minus 15 times x plus 2, and you're done. And you think, hey, here's my, look, please stop for just a moment. If I multiply that out, the first thing I get is x squared. I do not get a 5x squared, which is what I need, right? I need this 5x squared. This is not the factored form, or it's not the factored form of the quadratic I'm given. When a isn't 1, you're not finished. You can't write it down. When a is 1, your work is not done. What we need to do is we need to split this middle term up. So I'm going to write this now. I've got 5x squared, and I'm going to split the negative 13 up. Negative 13 is the same as negative 15x plus 2x. So again, this part right here, negative 15x plus 2x, that's equal to negative 13x. And then I've got this negative 6 still, and this equals 0. So that's the splitting part, right? I've split my linear term, negative 13x, into two parts, and the thing that guided me were these values, right? The negative 15 and the 2. Okay, now I'm going to use factoring by grouping. I'm going to consider my first two terms, and then I'm going to look at the second two terms. And I'm going to just pull out their greatest common factor each. The greatest common factor of my first two terms is 5x. So I'm going to factor out 5x. When I factor 5x out of those first two terms, right, what am I left with? Well, 5x squared divided by 5x is x. And negative 15x divided by 5x is negative 3. So I've got x minus 3. The next two terms, I've double underlined them. They have a common factor, a greatest common factor of 2. So I'm going to pull that 2 out. So I've got this plus 2. And when I factor out the 2 from those two terms, I'm left with an x and a minus 3. So I love how this looks because now all of a sudden I see this common binomial factor. Each of these two terms, right? And there are two terms. There's the plus that's separated in. I've got this term and then I've got the next term after it. Each of those terms have a common binomial factor of x minus 3. So I'm going to pull that out front. I'm factoring out the x minus 3. Now, when I bring the x minus 3 out front from both of them, what am I left with? I'm left with a 5x and a minus 2. And then finally that equals 0. So here's the factored form. And I can sit here and I can quickly multiply this, right? First times first. 5x times x is 5x squared, which checks. The next thing I have is I have a negative 2x and a, I'm sorry. I've done something wrong. Oh, I've done something terribly wrong. In fact, that was a nice video. I hate to stop this video just because of this little mistake I've made. The little mistake I made was that this x, this is a plus right here. And you know what? I guess I'm not going to stop the video because here's the truth, right? I was just multiplying these binomials. And in the act of multiplying, I immediately put the brakes on because I'm like, wait a minute, this is not giving me this quadratic. It's not giving me the thing that I started with right here. So this is how math happens, right? I'm moving along and I made a mistake, but because I'm multiplying this, I have to check it. I caught myself, right? So I guess I won't lie and say that I always do things perfectly. This is what happens. But this plus, right, it's 5x plus 2. This needs to be a positive 2. And I totally missed that sign right there. But now, because I was multiplying it, I caught myself. Now check it out. Now if I multiply this, right, x times 5x is 5x squared. And then I've got a plus 2x, and then I've got a minus 15x, right? That's the negative 3 times negative 5, and I already did this one. And then the last thing is I get a negative 6. Well, when I combine the 2x and the negative 15x, I get exactly negative 13x. So I can see, you know, oh, poor Mr. Robertson made a mistake. But look at this. I got 5x squared minus 13x minus 6. Now, that was me just checking to make sure I factor it right. Okay, now, if I want, what do? I got to get the roots here still. To get the roots, it's pretty simple, right? All I do is set each one of these equal to 0. So I've got x minus 3 equals 0. Therefore, x is equal to the number 3. There's one of the roots. The other one is 5x plus 2 equals 0. Therefore, 5x equals negative 2 and x equals negative 2/5. Fabulous. There's my other root. So the two roots are 3 and negative 2/5.